Hello friends, myself Rajendra Mahajan presenting my video on Laplace transform. Example, state and prove the convolution theorem of Laplace transform. Statement of the convolution theorem is like this. If inverse of f bar of s is equal to capital F of t and inverse Laplace of g bar of s as capital G of t, then inverse Laplace of the product of that two term f bar of s into g bar of s as integral from 0 to t f of u into g of t minus u with respect to u, and it is called as the convolution theorem. Then to prove this, let call that integral from 0 to t f of u into g of t minus u du as phi of t. Taking Laplace of phi of t, therefore Laplace transform of phi of t, as per the elementary definition, it is nothing but integration from 0 to infinity e raised to minus st into that phi of t and its integration with respect to t. Then it is integral from 0 to infinity e raised to minus st. Substitute the value of phi of t as integration from 0 to t f of u into g of t minus u du, and then dt. Therefore, this is nothing but double integration of integral from 0 to infinity inner integral from 0 to t of e raised to minus st f of u into g of t minus u, first with respect to u and then with respect to t. We call this equation 1. For the above double integration, the domain of the integration is the entire area between u is equal to 0 and u equal to t. And therefore, if we try to show it in the figure, on x-axis we take values of t, on y-axis we take the values of u. U equal to 0 means tx, u is equal to 0 and u is equal to t. A line passing through origin, angle of inclination is 45 degree. Therefore, we draw a strip between these two lines, vertical strip. Then by changing the order of integration, we get to show that change in order, we draw another strip. Here this is parallel to y-axis, original strip, then we make it parallel x-axis. And therefore, from the figure, that Laplace of phi of t as 0 to infinity lower end lies on the line u equal to t, means t is equal to u, and upper end lies on t equals to infinity. Therefore, this is the lower end. Equation is t is equal to u, and upper end we can extend up to infinity. E raised to minus st f of u g of t minus u. When we are changing the integration, change in the order of integration, first integration is performed with respect to t, and then with respect to u. Integration from 0 to infinity, integration from u to infinity, e raised to minus st, we can rewrite by subtracting su and plus su, so that original term e raised to minus st remains as it is. Only form I am changing. F of u g of t minus u dt, and then with respect to u. The integral is with respect to t, therefore that e raised to su become a constant term we take outside the inner integral from 0 to infinity as it is. E raised to minus su we take outside the integral sign, as well as f of u is a constant term we take outside the integral sign, inner integral sign. The remaining terms are u to infinity, it is t is equal to u to t is equal to infinity. E raised to minus st and plus su, g of t minus u, and dt, and then du. Once again I can rewrite that as 0 to infinity e raised to minus su f of u, integration from u to infinity e raised to, from this minus st plus su I can take minus s common, therefore it is t minus u g of t minus u dt, and then du. Suppose we call this equation 2. In equation 2, we put t minus u is equals to some new variable. Suppose v, differentiating it with respect to t, we get dt is equals to dv. Limits, new limits, for t equal to u, we get u minus u, means v as 0, and for t is equals to infinity, we get v is equals to, when t is infinity, infinity minus any number, we get infinity. Therefore, v is infinity. Substituting all this information in equation 2, we get, therefore, that is Laplace of phi of t is equals to integration from 0 to infinity e raised to minus su f of u, new limits. For u we get v equal to 0, and when u is infinity we get v as infinity e raised to minus s t minus u is v, and into g of v du dt is dv. Outer integral as it is, no change, 0 to infinity e raised to minus su f of u. As per definition of Laplace transform, integral from 0 to infinity sum e raised to minus st f of t dt is the Laplace of that, and therefore it is exactly similar to that, only t is replaced by v, and therefore that integral I can call as g bar of s, and then its integration with respect to u. Okay, with respect to u, g bar s is constant term, we take it outside. Integration from 0 to infinity e raised to minus su f of u du. Again, same elementary definition of Laplace transform. This integral from 0 to infinity e raised to minus su f of u with respect to u is f bar of s into g bar of s. We can rewrite that as f bar of s into g bar of s. And therefore, this is the proof of that theorem. Or we can transfer this L to other side. We get inverse Laplace of f bar of s into g bar of s as phi of t. What is phi of t? It is integral from 0 to t f of u into g of t minus u. Hence proved. Hence result is proved. Please like my video, share it, as well as subscribe to my channel, and to receive the notification for my new videos, please press the bell icon. Thank you. Thanks for watching.